All right, let's go over the review so that you have that done for the test, so that you're prepared for the test that you're going to take in the next day or so. First one, name the following ionic compounds. The first one says Al2SO3. So when you name that one, the first element is aluminum. And then the second SO3, that's the compound or the polyatomic ion sulfite. So that's aluminum sulfite. So you get that SO3 from that polyatomic chart that's in the Canvas page. Second one, letter B, is CS2O. That's cesium oxide. It's just the element oxygen, so it becomes oxide. Cesium oxide. Second one, I'll write the formula for this. Well, the first one, calcium bromide. So in order to do that one, you got calcium, Ca, that's a +2 from the periodic table. Then you got bromide, that's the element bromine, and he's a -1. Those don't cancel each other, so we've got to crisscross it, so we end up with CaBr2. Second one, gallium sulfate. We got gallium. Gallium from the periodic table is a +3. And then we have sulfate. Because it's 8, you got to go to that polyatomic ion chart, and it's SO4. I'm going to put it in parentheses for the fun of it. That's a -2. Those charges don't cancel each other, so we crisscross it. We got to put the 3 over here, the 2 over there, and we end up with Ga2SO43. All right, next one, name the molecular compound. So these are all molecular, so these use the mono-di-tri chart. So we got O2Cl5. So the first one is dioxygen, because you got 2 oxygens. Then you have 5 chlorines, so it's pentachloride. So dioxygen pentachloride. Second one, S3I7. This is trisulfur heptaiodide. Trisulfur heptaiodide. Then the next part is now write the formula for the molecular compounds. You have tetracarbon dioxide. So tetracarbon means C4. Dioxide means O2. So C4O2. Letter B, pentanitrogen tribromoid. So that's N5Br3. N5Br3. Number 5, name the following acids. Oh, naming the acids. So these ones, remember, you got to name it ionically. And then after you do it ionically, then you can change it to the acid name. So the first one, we have HF. So with HF, we're going to name this as hydrogen. And the second part is fluor, and it's fluorine, but we name it as fluoride. And the key thing is that last little piece there, the ide. Because it ends in ide, it becomes, for the acid name, it is hydro blank, and the blank is fluor. Then we make it ic. So it's hydrofluoric acid is the name of it, right? Now remember, this part in here, that's not the name, that's just the process to get to the name, okay? And because this ended in ide, it's hydroblankic acid, and we put the fluor in the middle. All right, next one is HNO3. HNO3. So this is hydrogen, name it ionically. NO3 is nitrate. We look at the end of that, it ends in 8, so it's 8 something icky. So it becomes nitra, and we make it ic acid. So this is nitric acid, and again, this is not the name, that's just a piece to get to it. Okay? All right, now we're going to work at the other direction. So now they're going to give us the name. So now I have hydrochloric. So I'll start that down here. Hydrochloric acid. All right, it's hydroblankic acid. So that means ionically it's hydrogen. And then we got chlor. Now what does it end in? Because it's hydroblankic, it's got to end in ide. So hydrogen chloride is H, which is a +1. Then we got chloride is Cl, that's a -1. Those two guys cancel each other, so it's HCl. All right, last one of these acids right now. We got nitrous acid. This one ends in us. So we're going to go hydrogen. And that's nitra. Ends in us, so remember white house. So this has got to be ite. So it's nitrite. So now we go hydrogen, which is +1. Nitrite from the polyatomic ion chart, that's HNO2 with a negative 1. Well, those two charges cancel each other, so it's HNO2 is the answer for that one. All right, now we got name the following. So these ones you have to figure out which type they are. So what you have to do is you have to look at the very first element that they're made up of. If the first element is a metal, then it's ionic. If the first element is a non-metal, then it's molecular, uses monoditri. If the first element is hydrogen, then it's an acid and uses the last process, the acid naming. So the first one we got H2SO4. Well, that one's got hydrogen at the beginning, so this is an acid. So we got to name it ionically and go hydrogen. Second part is sulfate. It ends in 8, so it's 8 something icky. So we go sulf, ick, and it actually is sulfuric acid. If you made it sulfic, I'm still going to count it right because you did what I taught you, which is the root, and then in an ick. But this one actually is sulfuric acid. All right, second one, we got NaBr. Well, Na is a metal on the periodic table because it's over on this side of the periodic table, so it's a metal. Because it's a metal, it's ionic. So if it's ionic, we're going to name this sodium bromide, and that's the name. The last one, letter C, we got N2F. So we got N. Well, N is up here. That's a nonmetal. Because it's a nonmetal, that means this is molecular. So now I got to use monoditri. So the first one I got 2 nitrogen, so it's dinitrogen. Then I have 1 fluorine, so it's monofluoride. Dinitrogen monofluoride. All right, number 8. Identify these as metals, nonmetals, or semimetals. So the first one we got hydrogen. He's up here. Well, everything that's on this side, these guys are all metals, except, don't forget the exception, except hydrogen. Hydrogen is a non-metal. He just acts like a metal. So the answer for hydrogen, non-metal. Aluminum, he's right here. He's right on that line with all the metalloids, except aluminum is the exception. He's a metal. So aluminum should be a metal. Then we have sulfur. Sulfur's over here. That's in the area of the non-metal, so he's a non-metal. Manganese is right, I'm trying to read it backwards. Mn is right there, manganese. He's on the side where the metals are, so he's a metal. Arsenic is right here. Oh, that one's on the stair step. So that means he's a semi-metal or metalloid. And then we have chlorine, which is over here. That's in the area of the non-metal, so that's a non-metal. All right, so remember those. All right, next page is some matching. So the first one, a positively charged ion. Positively charged ion is cation, letter C. Number 2, elements with properties of metals and nonmetals. Those are metalloids or semimetals, which is F. Number 3, the lowest whole number ratio in an ionic compound, that's the I, that's called a formula unit. It's just that lowest whole number ratio because sodium chloride would be NaCl, there's 1. We could also have Na2Cl2, we could have Na3Cl3. Well, we go to the lowest whole number ratio and we get Na1Cl1 or NaCl. That's called a formula unit. Number 4, compound with 3 different elements. Well, that's a ternary element, so that is L, ternary compound. Number 5, group of elements below the periodic table. That's letter D. Those are the inner transition metals, but remember they're not really below the periodic table. All right, these guys that are down here, down there, those guys are actually supposed to be up in here. They slide everything across and go in the middle. That's why they're inner transition. Number 6, negatively charged ion. That's A. That's an an ion. An means negative. 7, the group A elements. Group A elements, remember, are these guys. All right, the S and the P. The group A elements is K. That's representative elements. Number 8 shows the number of kinds of atoms in a molecule. That's G. That's the molecular formula. The formula that tells us how many there are in there. Number 9, compound with 2 nonmetals. If it's got 2 nonmetals, it's H. It's a molecular compound. Number 10, compound with 2 different elements. That's B. That's a binary compound. Binary meaning 2. Number 11, the group B elements. They're in the center. That's the orange ones on my periodic table. Those are M. That's the transition metals. Number 12, group of atoms bonded closely and is an ion, and I call it page 147 from the book. That is the polyatomic ions. That's J. Last one, number 13, compound made of a metal and a nonmetal. That's E. That's an ionic compound. All right, next one, you're supposed to sketch the periodic table, just a brief sketch. And what you should have is, you should have the stair step right here, and those guys are the semi-metals or metalloids. These guys over here, those are the non-metals, and everything that's over here, including the ones down below, those are all metals. All right, and then don't forget the exceptions. Hydrogen, it's on the metal side, but he's actually a non-metal. Aluminum, he's in the metalloids, but he's actually a metal. Okay. All right, last thing, we've got to do some elements, an ionic name, ionic formula, and number of electrons gained or lost. So the first one is the element S, which is sulfur. He's actually going to be a -2, because if I go to the periodic table, there's sulfur. Remember, it's 0, -1, -2. So he's got an ionic formula of S with a -2, and his name would be a sulfide ion because he's negative. And why is he negative? Because he gained 2 electrons. Second one, chlorine, he's right here, 0, -1. So his formula is Cl -1. His name, he's negative, so it's not chlorine, it's chloride ion. And why is he negative? Because he gained 1 electron. Boron, B, he's right here. So he happens to be in the +3 group. So it's B with a +3. His name, because he's positive, is just the element, boron ion. And he actually lost 3 electrons, is what made him have a +3 charge. Li, that's lithium. Lithium is way over here. He's got a +1 charge because he's in the first group. So it's Li +1. His name, lithium ion. And he lost 1 electron, that's why he's positively 1 charged. Magnesium is right here. He's in the group where it's +2. So it's Mg +2, his name, magnesium ion. And he lost 2 electrons. All right, now the questions. Number 12, describe 2 ways that an ion forms from an atom. How do we get an ion? Number 1 is they lose electrons or they gain electrons. That's the way in which you can make an ion. They're either going to lose electrons, which makes them positive, or they gain electrons, which makes them negative. Number 13. This one, you're supposed to state the number of electrons either lost or gained in forming each ion. So you got Br with a -1. Because he's -1, he actually gained 1. Now don't think that -1 means subtract 1. It's the opposite of what you think mathematically. If you think of it as subtract 1, it means he gained 1 electron because that 1 electron is a negative charge. All right, second one, Na +1. +1, opposite of that means he lost 1 electron. As -3. Well, -3, the opposite of that means he gained 3 electrons. Ca +2, opposite of that means he lost 2 electrons. Cu +1 is he lost 1 electron. And then we got H with a -1, that means he gained 1 electron. Number 14, we're supposed to name these. So it's to name each ion and then identify as an anion or cation. So Br -1, that's a bromide ion because he's negative. And that means it's an anion. Then we got Na +1, that's a sodium ion. That's a cation because it's positive. As -3 is an arsenide, and that's an anion. Ca +2, that's a calcium ion because it's positive, it just stays the same, and that's a cation. Cu +1, that's a copper ion, that's a cation. Last one, a really unique one. Usually H is always +1, but this is the rare case when he's a -1. Because he's negative, it ends in I, it becomes hydride ion, and that's an anion. It's pretty rare, but it does happen rarely. All right, I'm going to go to part number 2 because I'm just out of time for this one. So see you in part number 2.